Welcome to everyone for the presentation. Myself, Sajib Ahmed, researcher from University Malaya, Malaysia. On behalf of my co-authors, I would like to present you a topic, comparative analysis of conventional and modified P&O MPPT controllers under partial shading conditions. These are the objectives of my presentation. Design and implementation of conventional P&O algorithm. Find out the drawbacks of conventional P&O algorithm. Design and implementation of 3 different modified P&O algorithms to mitigate the major drawbacks of conventional P&O algorithm. Comparison of the performances of the algorithms based on simulation results. Drawback of conventional P&O algorithm is as under: oscillates at steady state condition, unable to track the GMPP in case of partial shading conditions. The range of tracking is local search space only. In case of indirect control method, need to tune the PI parameters. To mitigate the major drawbacks of conventional P&O algorithms, 3 modified P&O algorithms are designed here, which are able to improve the performances of conventional P&O algorithm at different aspects. Name of the algorithms I am going to discuss in this presentation is conventional P&O algorithm and 3 different modified P&O algorithm, namely different step size method, scanning method, and trapezium method. This is the flowchart diagram of conventional P&O algorithm. Its operation is based on perturbation of the voltage and observation of the power. If power increase by increasing voltage, duty cycle requires to decrease. If power increase by decreasing voltage, duty cycles requires to increase. Alternatively, if power decrease by increasing voltage, duty cycle require to increase, and if power decrease by decreasing voltage, duty cycle require to decrease. This diagram is for different step size method. This method is same as conventional P&O algorithm. Exception is the duty cycle step size. Algorithm uses large step of duty cycle during convergence to the peak and small step size of duty cycle at steady state conditions. This diagram is for scanning method. In this method, algorithm starts scanning from middle of the PV curve towards the right direction until satisfying of an end criteria, and after that scans from right to left direction until satisfying of an end criteria. During scanning process, array voltage is continuously sampled and corresponding voltage and current are recorded. At any instances, if power is greater than previous maximum power, then corresponding power and voltage are updated. At end of the scanning process, reference voltage is bring at voltage corresponding to maximum power, and conventional P&O algorithm is applied to track the GMPP. This is the flowchart diagram of trapezium method. The working procedure of this method is similar to scanning method. The main exception is the end criteria of scanning at both left and right direction. This is the PV curve for partial shading pattern. We used 4 modules, so they have 4 peaks. Among the 4 peak, one is global maximum peak and other 3 are local maximum peak. This is the output power, voltage, current, and duty cycle curve from the simulation result. In case of conventional P&O algorithm, we can see here that the algorithm failed to track the GMPP and trapped at LMPP, and tracking time is 0.016 seconds. These are output curves for different step size method. Like the conventional P&O algorithm, this algorithm also trapped at LMPP, but tracking time and steady state oscillations are improved comparing to conventional P&O algorithm. This curves is for scanning method. In this case, the algorithm successfully tracked the GMPP at a tracking speed of 0.175 seconds. Tracking speed is higher than conventional algorithm because this method needs to scan the whole PV curve to find the GMPP. This curves is for trapezium method. Like the scanning method, this method also successfully tracked the GMPP with a tracking speed of 0.125 seconds, which is less than the scanning method. Now I'll draw the conclusion of my presentation. From the simulation results, it has been found that modified P&O algorithms have improved the performance of conventional P&O algorithm on different aspects, whereas different step size method have improved the steady state oscillation and tracking time comparing to conventional P&O algorithm, but still unable to track the GMPP. The scanning method and the trapezium method track the GMPP at all the partial shading patterns, but tracking time and steady state oscillation is higher than conventional P&O algorithm, which is the shortcoming of these methods. The trapezium method outperformed the scanning method based on tracking time. Please don't hesitate to ask if you have any questions.